If we want to solve these equations, notice that in both examples, there's a log on one side and a log on the other side. Our main strategy is to get one log by itself equal to everything else. So I want to move the logs to the same side so that I can push them together to make a single log. So I'm going to move this minus log base 2 of x plus 5 by adding log base 2 of x plus 5 to both sides. Now that my two logarithms are on the same side equal to 3, I'm going to use the property that when we push addition together, it becomes multiplication of the arguments. So I'm going to have log base 2 of x plus 7 multiplied by x plus 5. Then as soon as you have a single log, we're ready to change to exponential. So that 2 tunnels under pushes that 3 up. So it's 2 to the power of 3 equals, and then the log is gone. Also, have had a couple people accidentally putting this number in the wrong place. Just think about vocabulary. This is a base, log base 2, and on this power, 2 is a base and 3 is an exponent. So the base became a base. Okay, now we have an equation to solve, and we want to multiply these together. So if I FOIL, I'm going to have x squared, and then x times 5 is 5x, and x times 7 is 7x. So 5x and 7x make 12x, and 7 times 5 is 35, and then 2 times 2 times 2 is 8. We're going to move everything to the same side equal to 0 so that I can either use the quadratic formula or factor. Most of these you're going to be able to factor. So I subtracted over 8. Thinking of two numbers that multiply together to get 27 and add up to 12. That's going to be 3 and 9. Okay, so I have x plus 9 times x plus 3 equals 0. If two things multiply together to get 0, then one of them has to be 0. So to find what numbers make those pieces, those factors equal 0, we're going to set each piece equal to 0. Subtract 9. So one of my answers is -9. Subtract 3, and my other answer is -3. But remember that once you have your answers, if your original equation has a logarithm of x, you must check. Okay, so if I substitute in -9 here and here, -9 plus 7 is -2. I would be taking the log of a negative number. That cannot happen. So since that cannot happen, this answer is extraneous. It needs to be thrown out. So this one's not an answer. Okay, then I want to check -3. If I substitute -3 back in the original, -3 plus 7 is a positive, -3 plus 5 is a positive, so I am going to be taking a log of a positive number, so I'm okay. So this answer is kept. And that one is my final answer there. X minus x is -3. Okay, so this one, again, logs are on both sides. So I'm going to move that log to the other side by subtracting it. Now that they're on the same side, my goal is to write a single log equals to something so I can go to exponential notation. I can push subtraction together with division. So I'm going to have log base 5 of x minus 7 in the numerator and x minus 3 in the denominator. Now that I have a single log, I'm going to go exponential. So that 5 tunnels under. So I'm going to have 5 to the power of 1. That log is gone. Okay, so I have x minus 7 over x minus 3 equals 5 to the first, which is just 5. Okay, my equation has a fraction in it, so our number one strategy for when equations have fractions is multiply both sides by the denominator. Nice job. So I'm going to multiply both sides by x minus 3. Those cancel, leaving me with x minus 7. And on this side I have 5 times x minus 3. I went ahead and just distributed that. So 5 times x is 5x, and 5 times negative 3 is negative 15. Letters on one side, numbers on the other. So I'm going to subtract 5x, giving me negative 4x on the left. Add 7, and that gives me negative 8 on the right. Divide both sides by negative 4, and I get positive 2. But you've got to remember on these ones, it's not optional when your original equation has a log of x in the original. So I wanna check this. So I'm gonna put 2 in the original, and 2 minus 7 is negative 5. I don't really need to check any further. I would be taking the log of a negative number. So this one is gonna have to be thrown out, which means that I have no real solution. When you're checking, one more time, you cannot take the logarithm of 0 or a negative number. So if you substitute the number you get back into the original and you end up taking the log of 0 or the log of a negative number, then that one is an extraneous solution and you want to throw it out.